All right, so this video is going to be for those of you who either missed our first lesson when we were using the Tinkercad circuits, maybe you fell behind a little bit, maybe your internet connection was out, but I want to make sure that everybody understands the basics of creating our circuits and then programming and how to use this Tinkercad. Sounds like we might be using Tinkercad for another week or so before the IT team gets this figured out. So, without further ado, the first thing that you need to do is you need to make sure that you are in circuits, okay? So default is designs. That's not where we want to be. We want to be in circuits, and then we want to create a new circuit. So that's the first thing we're going to do. And then after we've done that, before we even get into building the circuit, we need to change this name. This neat crunk go-go, I don't even know what that means, okay? So you need to change it to your last name, and then underscore, and then it's just first project, or sorry, first program. So we're going to actually be writing our first program today in the Arduino code. So whatever your last name is, put that down. Underscore, first program, done. Okay, next thing we're going to do is actually build the circuit. So we're going to start with an Arduino. So if I click one time, and then I just hover over, and then wherever I want it to be placed, I'll just click one more time and that'll lock it in. That'll be good. I can zoom out and zoom in using the click wheel on my mouse. So you should still have your mouse. Go ahead and do that if you need to zoom in or zoom out. And the next thing we need is a breadboard. So we'll click once, again bring it out to the space, click again. We should have an Arduino, we should have a breadboard. Okay, the next part of this circuit, we're actually going to add in some LEDs, okay? So in order to add in the LEDs, we got to start with the actual LEDs themselves. So we're going to need 3 total in the circuit, and we're going to want to change their colors. So pay attention to what I do. First LED, we'll go ahead put that in row 5 and 6. So cathode row 5, anode row 6. Color, I want this one to be green. Then I'm going to do another LED. This time we'll put it at 15. 15. And again, this one we're going to change the color to yellow. And then the last one, 25. And we're going to leave that one red. So we got all of our LEDs in there. So now we can make a traffic light, and that's going to be our goal. Okay, the next thing that we need to add in is the resistors. So we need the resistors to be connected from the cathode to the negative power rail. So if I click on this resistor, you notice I can place it so that one leg is in the negative power rail and the other leg is in the same row of the breadboard as the resistor. So I'll add in 1. Now I need to change the resistance. 1000 ohms would make this a really, really dim light. So I'm going to change this from kilo ohms to ohms, and I want this to be 220 ohms. So we need that for all of our LEDs, so we'll go ahead and do that. Make sure that you change from kilo ohms to ohms. We know what that prefix kilo means 1,000. We don't want 1,000, 220,000 ohms resistance. We wouldn't have any light. There would be not enough current to turn on that LED. And here's our last one. Again, 220, not kilo ohms. This needs to be in ohms. Okay, so we've got all of our LEDs. We've got all the resistors in there so we don't blow out our LEDs. So then the next thing that we're going to do is we're going to connect all these resistors, which are connected to the cathodes. We're going to connect them to the negative side of the power source, or we can think it would be like the negative part of the battery. Well, in this case, we're not actually going to be using a battery. We're going to be using the Arduino to power. And so the negative power source on the Arduino is the GND. So we can connect this power rail, the negative power rail, to the GND, and now all 3 of these resistors, which are connected to the cathodes, so all 3 of these cathodes are now connected to our ground, which is our negative. And usually we use black as the color to denote that this is going to the negative. So we'll go ahead and change that. To change the color of the wire, all you do is click on the wire itself, and then you'd use this drop-down wire color menu. Okay, so we've got all the negative sides done, which is great. So then the last thing that we need to do before we can start to do the programming is actually connect each one of these anodes to a different output pin. So we can use pins 2 all the way through 13. We can't use 0 or 1. 0 and 1 are used for special transmissions. So if you're trying to use like an LCD screen or something like that, that would be like a stream of data. We're not going to be using 0 or 1, but we are going to be using 2 through 13. So the first one I'll connect is this 2 to my 26. And because this is positive, I'm going to change this wire to be red so I know, don't get confused there. Positive to positive, which is my anode. I'm going to do the same thing. So the next one I'll do, let's do pin. Okay, so these are not negatives. These are not negatives. It's a squiggly line and then a 5. So these are all digital pins. But if it has a squiggly next to it, it means that it can act as an analog pin. And you don't need to really know too much about that other than all digital pins can send is either a high voltage or a low voltage. Analog pins can send anything in between. So if you were just doing a 1 or a 0 or on or off, you use the digital. If you want to do a range of values, you would use the analog. So you couldn't use 4 to do an analog. You could use 5, 6, 3, 10, 11. But we can also use those for digital pins as well. So it's not negative. People have been making that mistake. Make sure you don't fall victim to that. Okay, so then I can choose any of these. Like I said, I could choose this 5. Sure, I'll choose 5. And we'll go to 16 there. And then maybe for the last one, we'll do 12. And we'll go to 6. So I know that my 12, pin 12, is powering my green light. Pin 5 is powering my yellow light. Pin 2 is powering my red light. Again, that's going to be important when we get into the actual code. Okay, so let's look at it. Well, right now we just have a bunch of blocks, and this is like for young kids. This is not for you. So we got to get out of the blocks. We got to go to text. Continue. And now this looks more like something that we can use to actually program. So if you remember from class, I said there were 2 different parts of any Arduino sketch, and that is the void setup and the void loop. Notice how the void setup always has the parentheses, nothing inside them. After you have void setup parentheses, then you have an open bracket. So this is saying this is the start of where we're going to put all the information. So the next line is actually the first direction of the void setup. And then when we're actually finished, then we have this closed bracket. And again, that closed bracket is just saying that this is the end of the void setup. So make sure it's closed. Same thing with the void loop. We have to have the parentheses, we have to have the open bracket, then we have all the directions, and then we have our closed bracket. Okay. So right now, pin 13 is set up, but we don't even need to set up pin 13 because that's not being used. So we can change this one to 12 because that is one that we need to set up. But we're going to set it up as an output because remember, we're sending out an electrical signal. Pin mode 12, pin mode 5 needs to also be an output. Notice how I did not put any squiggle or negative in there. It's just a 5. We're using the digital pin. And then my last pin mode that I need to set up is pin 2, and I need to set that up as an output. Notice how after each of these lines, I have a semicolon. If you don't have the semicolon there, then you're going to run into an error when you try to actually start the simulation. Okay, so let's just look really quickly back at the circuit. So we set up pin 2 as an output. Cool, so now we can use this pin to turn on this light. We set up 5 as an output. So now we can use this pin 5 to turn on this yellow light. And then we set up pin 12 as an output. So now we can use this pin 12 to turn on or off the green light. And that's what we're going to do in this next section. So the next section is the void loop. Okay, so in this scenario, I want to create a traffic light where I'm going from my green to my yellow and then to my red. And the time that the light is on green should be a lot longer than it is on yellow, and the time that it's on red should be a lot longer than yellow. So if we're turning on green, we would need to digital write that pin 12, because remember, pin 12 is what's powering our green LED, to high, and we would need to wait for 1,000 milliseconds. Well, not only do we need pin 12 to be on high, we need the other two lights to be off because we can't confuse people. If you have a red light and a green light at the same time, that would be bad. You do not want to do that. So in addition to having our digital write 12 high, we're also going to do a digital write, which is just send electrical signal, for pin 5 to be low. And we also need a digital write. Oops, I spelled digital right. Digital write. And 2 for our red light would need to be on low. And then this delay 1000. So remember, the unit is not seconds, it's milliseconds. So this is delaying for 1000 milliseconds, or 1 second. So let's go ahead and let's change that to 5 so that we can turn this green light on for 5 seconds. And that'll be our first kind of section there. So we can put spaces in. Any space is just ignored by the Arduino when it's actually reading this code. So then the next thing that we would want to do is we want to turn off our green light. So to turn off the green light, that's pin 12. And we're going to now digital write that to be low. Well, if we're turning off the green light, we want the red light to still be off. So red light 2, that's already low, no problem there. So we don't have to worry about that. But then we would need to turn on the yellow light. So to turn on the yellow light, we're doing digital write. This yellow light, the anode is connected to pin 5, so we're going to use 5 as that pin. And we want to send it a high voltage. Don't forget your semicolon at the end there. And this time, we want to make that yellow happen kind of quick. So instead of it being a whole second delay, let's go ahead and make that a half a second, or 500 milliseconds. So this would say wait 500 milliseconds. So the yellow light will not be on for very long. It's going to do that quick transition, and then boom, switch to our final state, which is our red. So if we want to do that, let's think about this. We need to turn the yellow light off. So that's digital write. Five, low. So that'll turn off that yellow light. Then we need to turn on the red light. So our red light, again, that's digital write. And then the red light is pin 2 high. Okay. Now notice I didn't do anything in these second two with the light that was not affected. So remember, the red was already turned off. Digital write low. So it's going to stay like that until we send it to digital write high. So that's going to stay digital write low, not going to change. Okay. And then here, we had to only change the 2 states. So we had to change the pin 5 to be high so we could turn on the yellow. And then we had to turn the green off. But the red, it's already still off. So that's no problem at all. And then the last thing is turning the yellow off and turning the green on. Okay. So let's see if it works. Oh, I see the problem. So I didn't do a delay on my last one. So that's where my problem is. Whoops. I need to add in one final delay. For red, we'll turn on for maybe 2000. So 2 seconds. That'll be the red. Okay, now let's see. So first, green should be on for 5 seconds. And then a quick flash from yellow to red, and then red will be on for 2. Green. Boom, quick flash, yellow, 1 Mississippi, 2 Mississippi. And we're back. Okay? So this is the circuit that you would need to have to get those points. So if you initially got a 0 on this, please make sure that you go back, that you have this correct code, that you have this correct circuit set up. In our next class, we're actually going to be using the input feature. So we're going to be setting some of these buttons or these pins to be inputs. and then we can turn the light on or off based on whether or not that button's being pressed. So, hope this helped. We'll see you next class.